All right, good morning, ladies and gentlemen. Hope you are enjoying your time away from school. Your e-learning assignment today is going to focus on just taking a few notes here, and then there'll be a quick a check for understanding for you to do on Schoology. This is just a review of what we were talking about yesterday or Wednesday, the last time I saw you. But remember, the last time I saw you, we talked about density. So in your notes, so get out a blank sheet of paper, and we're going to take a few notes on density. So if you remember, we talked about density as being how tightly packed the matter in an object is. Right, and so specifically, if we were to draw this at the microscopic level, remember all matter is made of atoms, and at the microscopic level, if something is dense, all those atoms are squished in really close to each other. So this is a dense object, the atom's a dense object, and this is I guess I should say that's a more dense object. A less dense object has the atoms spread out more. And then the next thing we said was that when things are more dense, they tend to sink, and when things are less dense, they tend to float. So, pardon me, if you have two objects or two liquids, whichever one is less dense floats on top of the water, or floats on top. Whichever is more dense sinks. And so we could, for example, a lot of times if you take a cup here, right, and we've done this thing in class where we've filled the cup with water, which, remember, has a density, which you need to know. The density of water is 1 gram per milliliter. And then if we've done that thing in class where we put oil on top. And that's because oil has less density than water, so it's going to float on top. If I then poured something else in here, like let's say honey. Honey has a very high density. It's denser than water. And so honey would then sink to the bottom. So basically, the more materials you add, right, whatever is dense is going to sink to the bottom. Whatever is less dense is going to float to the top. The other thing we had discussed about density yesterday was we had this equation that density equals mass divided by volume. And I want to remind you how to approach problems like this. So particularly, let's imagine a problem that said, find the volume of a liquid that has a density of 1.3 grams per milliliter and a mass of 7 grams. So remember, the way that we did this was we started by writing out our knowns and unknowns. So we say this 1.3 grams per milliliter is a density. So I'm going to actually write D equals 1.3 grams per milliliter. This 7 grams is a mass, and I'm trying to find my volume. So those are my knowns and unknowns. Now if I go to plug into my equation, D equals M over V, and I plug these numbers in where they go, I get 1.3 equals 7 divided by v. And how do you solve this? Well, if you recall, whenever the variable is on the bottom, you can't solve it outright. The first thing you have to do is get the variable on the top. And the way we're going to do that is multiply both sides by v. These v's cancel, and I'm left with v times 1.3 equals 7. Then I can divide by both sides by 1.3. I don't have a calculator on me. Let me look here. So, let me see here.